Hello, friends. Welcome to another episode of the AI Show. My name is Seth Juarez, and I'm coming to you from my house. Pretty excited today. We got a fun episode, I think. Hopefully everyone will help me code this time. Last time everyone was super helpful. Again, the AI Show is designed to help us all look at AI in a pragmatic way without all of the extra fluff. Welcome. I'd love to hear where everyone's from. If you are here, let me know where you're coming from. Today, my friends, I am excited to tell you about what we're doing today. I've got my handy dandy marker thing here. One of my expenses that I needed over this interesting time. All right, so Jay is coming from downtown Seattle. Jay, we could go have lunch, but awkward times. Am I right? Kevin, hello from Wisconsin, my friend. You know, Wisconsin is awesome. There is a conference that I sometimes go to called That Conference. Which conference, you say? That Conference. Yeah, it's pretty cool. Like I said, I drove through there a couple of times trying to get to that conference, and it was pretty fun. So, by the way, did you like the skills as I transitioned the music? Yeah, it's called, Kevin's like, hey, I've never heard of that one. Yeah, it's called literally That Conference. That Conference. So for today, we have, let me go to this. Let's go to this so y'all can see me writing. Number one for today, anomaly detection. Detection. Smiley face with Tony. Xing. About that. So, here's the deal about that. So I want to be upfront with y'all. He's in China, and currently in Beijing. Let's see what time is it in Beijing. I'm gonna look it up on my phone. Okay. Current time in Beijing. Let's see here. Current time in Beijing. It is 2:03 in the morning. And so earlier this week, because I met with him at 5 p.m. because we like to go over things, right? Be like, hey, what are you going to talk about? That way it's not like we don't have like an awkward sitch. Is that what the kids say now? Awkward sitch. So we don't have an awkward sitch. We go over stuff, and I'm like, Tony, are you really coming on at 2 in the morning? He's like, well, yeah, if I have to. I'm like, no. So I actually met with him yesterday around 6 p.m., 5 p.m. my time, and we had a little discussion. So I'll play it here, and then I'll answer any questions. So just want to tell you that, just so you know. It's not like I have a really fast wardrobe change, because I can do it if I need to. But it was basically, I did not want, I didn't want him to have to be on here like it. 2 in the morning. So, okay. Number 2. Let's go back to this beautiful shot here. Number 2. We are going to be continuing on our Roshambo project. Roshambo. I heard a little ding ding. That's from, if you hear that little bling, that's coming from Learn TV. What is the steps to build AI? That's a good question. That's from Learn TV, by the way. Learn TV is the only channel where if you message me, you'll hear bling, because it's just the way I got it set up. So if you're on Learn TV, yes. aka.ms Learn TV, you can do that. But otherwise, I get all the other chats everywhere else too. So feel free to talk back. Wow, it just got sad in here. I'm going to turn that up. Sad. It's like birds and stuff. Roshambo. So what we're gonna do is, number 1, Aishigul, who runs the AI show on the weeks that I'm not on, had a really good idea about how to organize our projects, and I totally am stealing her idea. So we're gonna go there for a bit and see how we should organize stuff. You can give me some tips. I've never done GitHub projects before or discussions. It's all brand new to me. So we can all learn together. Together. So we'll learn together. Wow, this feels like I'm in a spa or something. Or like some fancy yoga. You know what I'm saying? Where they're like, now put your hand behind your back and touch the bottoms of your feet. And you're like, what? I can't bend that way. All right, so Roshambo project. What we're gonna do is we're gonna clean. Oops, this is the eraser. Almost messed everything up. we're going to clean up our project. I'm going to turn this down because I can't stop thinking about like yoga that I can't do. Maybe we'll go to the next song. That's better. So we're going to clean up the project because you remember I started with some garbage code. Well, garbage that I wrote. And we've been systematically moving it over to PyTorch Lightning. And I think we got it to work last time. I'm going to try to see if I can't figure out how to pass more flags in after I clean up the project. Oops. Let me put this here. Flags. Okay, flags so that I can, when I run it, I can pass in whatever I want for running. And then hopefully, let's move this up here. After that, we'll see where we go from there. And then again, we're going to look at the GitHub projects plus GitHub discussion. Hola, DF Mera. Hola, señor Seth. ¿Cómo estamos? Yeah, Kevin, definitely very soothing for a Friday afternoon. Like I said, my wife is like, you need to be a little bit more flexible. Let's do some yoga. And I tried doing yoga one time. I don't think I was supposed to bend that way. All right, did you hear that? There's a little bling bling from the Learn TV. Hot yoga in the dark. That's the only way you're going to want to do yoga with me. You don't want to see this doing yoga things. Thank you, Robert McDonald on Learn TV. By the way, like I said, if you message me on Learn TV, it'll make that sound because of the way I set up my soundboard. Maybe I should do one episode where I show my setup because, like I said, I've been at home for a while and I started buying stuff to assuage the inner turmoil. Not healthy. Maybe I should have just gone to a therapist. So this is what we're doing today. It's going to take us throughout the 2 hours. Like I said, Tony is in China. It's 2 a.m. for him. And I was like, Tony, come on, dude. I don't want you up at 2 a.m. trying to do a demo. So he's not going to do that. And by the way, keep your questions coming. Tony's, it's about 15 minutes of stuff with Tony. Another Learn TV. Bling, bling, bling. What do we got going on here? Okay, next week will be AI week. You sold me. No, this week, Robert, is AI week, but not yoga. Remember, like I said, there's some times where they're like, okay, now put your right index pinky. I'm like, right index pinky behind your head and touch the soles of your feet. You should feel a little tension. I'm like, what? Jay's like, therapy might be more expensive, but probably more useful. Maybe? I don't know. All right. So that's what we're doing today, anomaly detection. I thought we would start with Tony. I'm going to do a quick wardrobe change. And we'll, how about we go from there? All right. So let's go to Tony. Let's see if I can do this. Here we go. And now, hopefully, here is Tony. I don't want to miss this episode of the AI Show where Tony Xing takes us through what's new to Anomaly Detector multivariate capabilities. Make sure you tune in. Hello and welcome to this episode of the AI Show. We're learning all about what's new in Anomaly Detector multivariate capabilities. Tony Xing is with us. How you doing, my friend? Why don't you tell us who you are and what you do?
Very good. How are you, Seth? So I'm the product PM of Azure Cloud Service. So specifically working on Anomaly Detector Matrix Wider.
Fantastic. So let's start with, for those that don't know what Anomaly Detector is, can you give us a little bit of an overview of what the service does?
Yes. So Anomaly Detector basically is the AI service which help people to identify the anomaly in the time series data. And then, so this new capability is actually advancement of the AI that we could use a group of signal to identify a system level issues.
I see. So the new stuff. So before the anomaly detector, what it does is it takes a signal of stuff and it tells you when things are out of the ordinary. Basically, is that right?
That is correct.
Fantastic. So the new thing, multivariate anomaly detection. What does that mean?
Yeah, multivariate is basically multiple signals. So previously, the existing feature basically tell you based on one single signal and tell you, hey, there's something goes wrong. But there's actually a broader use case that, for example, the equipment health, you have probably more than 100 signals you need to make sense of. And let me give you a quick example. For example, you have a refrigerator which has 3 sensors: temperature, vibration, lights. But each of those sensors won't tell you too much about whether that refrigerator is working in a healthy mode or not. But holistically, if you look at all those sensors together, you can pretty much say, hey, this one is not working or is working correctly. So that is basically multivariate anomaly detection.
That's cool. So before the service would tell you if there was a single signal that was anomalous, but now if you have multiple signals together, they can tell you if they're anomalous, even though one of them by themselves might not be anomalous. Is that right?
Yeah, that is perfect. Yeah.
All right. So can you show us how it works?
Sure. So let me switch to the Jupyter Notebook. Before I go to this more code level things, I just want to show you the visuals because I know people love visuals and it's more easier to understand. So here is a very simple use case. We have 5 time series and all of them are pretty much random, right? So if you look at those 5 signals together, so those are basically some real production signal taken from some real use case in sensors. If you look at those, pretty much you cannot really make sense of those. But with the state-of-art AI, we can look at these things holistically and use long history to train and to learn what the normal pattern will be like. And then as a result, you can see, hey, those the spikes here is basically the output generated from this model. So those are basically the markers that we say, hey, at this time stamp, we see that this group of signal has a problem, meaning that from system level, this equipment has a problem. And then, so this is pretty much can tell you, whether system level there's an issue, and you can actually do some fine tuning with the output. For example, with the severity parameters, you can tune the model performance, and as a result, you can see more or less anomaly being marked here. So let me scroll to the top and give you an overview about the API first.
Got it.
Yeah. So here, the API, so we introduced about 7 new APIs, list models, train models, gather model, delete model, so those things. But most important thing is that, so this is basically a 2-phase approach, right? So you first, based on the historical data, you train a model. And this training is you basically unsupervised approach. You don't need a label specifically. So what you input is a series of time series, and then after the training, you get a model ID, and then you can use that model to do the inferencing, and then use the output result to do the anomaly detection. And not only you get anomaly detection result, the more beautiful thing is that you also get the contributor ranking. For example, that is very useful. For example, you can say, hey, we detect this anomaly and we know which sensor is top contributor and how relevant they are in terms of contributing to these anomalies.
And in this case, it would be, instead of a single signal, it's multiple signals. I'm looking at the API here, and there's a whole new, REST API for multivariate. So it's multiple signals now that can actually together tell you if there's a problem.
That is correct.
Got it.
Correct. Yeah. And then to use that, this RESTful API is very easy. So you basically, create a resource and get your endpoint and get your key. And after that, so then you can start to use those models. So let me just quickly run through. We have trained some models. So previously, you can see this run successfully and list all the models. So this is the result is a little bit messy, but here's the sample response in a more clean structure. Right. So you can pretty much see, hey, this model is created at this time, and what is model ID, weather status, and how many variable has been used to train this model. So here is 18 variables, and then after that, you can actually do the training. So I will not do the training here because this takes some time. But what it does is that it will, basically taking in a zip file. In that zip file, you put that in an Azure blob. And in that zip file, you have a bunch of CSVs. Each CSV file represents one variable. And then, so you basically, provide those as input of the API. And then this is basically the sample request. And as a response, you will get a model ID you can use in the future, for the, status scoring, because the model training will take some time. The result itself will, reply back with some of the additional, you can use additional API, for example, this one, to get a model status because the training will take some time.
Can you go back 1 second? I want to make sure that I'm understanding it right. The part where you submit the model training, you're basically giving it a blob file. Is that right?
Yes, that is correct.
Can you scroll up to that part? Because I want to make sure that everyone sees that part, because that's the part that I was like, well, how do you give it all of the data? Because it has a bunch. There it is. So basically, when you post, you're telling it exactly what data you want it to look at. And since it's multivariate, you're going to have a bunch of series in different CSV files that have been zipped up. Is that right?
That is very correct.
Okay, cool. Okay, cool. Because that was a part that was a little confusing to me initially. It's like, well, how does it get all the data? This makes perfect sense. I'm sorry. Keep going.
Yeah, no problem. So when the training happens, you may want to, get the status of the training, and then you use the multivariate model status API. And then as a result, so here, this is very important, this is epoch ID. So you will return from 10 to 100. So this one will pretty much tell you about, what's the percentage this model training are progressing. So it's 100 epoch in total. So, use this and the latency in second, you will pretty much predict when this model training will probably complete. So once it is complete, you can use that for the inferencing with the, detection API. So here you again, use the new data you want to inference and put that in a similar fashion at the block file, and then post that to the inferencing endpoint.
So
And
just to
then,
pause there. So now that the model's done, if you wanted to actually do the predictions, then you give it another blob file and say, hey, predict on this new data. Is that right?
yeah, that is correct. Yeah.
Cool.
And then, so the result of this API, it is a result ID. The result ID is the one you will be using, to get the final detection result, the more detailed detection result. So this one is, very useful and interesting because the output of this prediction result, there's a lot of information you can use to do either the visualization and also like I mentioned earlier about the contribution factors. So for example, which variables, which sensors actually contribute more to these anomalies, and how you rank that. Um, yeah, so this is obviously the response of this one. And then let me see what is the, yeah, the here in this section, the response part is very most useful part. So whether this timestamp is anomaly, and what is severity, what is the raw score, and then you can hear in this part the contribution ranking score you can use to basically see how those variables ranked among this group, and you can use that as a kind of root cause analysis because you may want to understand, hey, this system level anomalies actually contribute more by these vibration sensors.
That's cool.
Yeah. Um, yeah, so everything else you basically can, based on all those rich information to, do some plot and visualizations. So here is the basically we are going back to the previous visualization I showed you at the start of the show. And then so here's basically the five variables and whether that is anomaly and the raw score and the severities.
So basically, once you send the data, the one thing I didn't understand is once you send the data to do the inference, how does the data come back? Is the data stored somewhere? Because I saw the response type, and the response type is basically telling you where the anomalies are, and that's what you're plotting there at the bottom. Is that right?
Yeah, that is right. All the information are in the response body. Yeah.
Got it. This is cool. So is there anybody using this, and how's it working for them?
Right, it's a great information, great question. So we have in our private preview working with some of the well-known company like Siemens, Airbus. So they have done the early piloting. So everything looks good, and they have very accurate result. For example, Siemens used that in medical equipment testing. Uh, you know, uh, their scenario is pretty much in the pre-production they do intensive testing on their machines, and then you can imagine on that machine there's a lot of sensors. So they use that sensor data to make sense of whether this equipment is good to go or not. Airbus is in a similar scenarios. For example, there's potentially hundreds of signals from satellite or the airplanes. So they are doing this predictive maintenance things through the multivariate anomaly detection. Yeah.
Well, this is really cool. Where can people go to find out more?
Yeah, so there's we have a few links, posted here, so people can read blogs and find out additional information about how to write code and how to construct a more complicated solution out of it.
Well, this has been awesome, my friend. Thanks so much for spending some time with us. And thank you so much for watching. We're learning about what's new to Anomaly Detector multivariate capabilities. Thank you so much. Thank you so much for watching, and hopefully we'll see you next time. Take care. How about them apples? Hold on. Let's see. Let's go back. Let's see what past Seth looks like. Hold on. There. All right. So, question here: red shirt or blue shirt? That's the real question. Actually, no. There's other questions. If anybody has any questions about Anomaly Detector, I will take them. I know a little bit about them. The thing that's cool about this, and here I can turn the music back on. The thing that's cool about this is generally with sequence modeling, you have a single sequence that you find anomalies with. But it turns out that just a single sequence in aggregate might not necessarily tell you where the anomalies are. But if you have multiple things, there's some cross correlations that may happen that will enable you to find other anomalies that you may not have found. Did the shirt even change, Jay McCormick? Or red and blue shirt? Yeah. Like, we don't even know which one is the real Seth. Right? Which one's the real Seth? Is it me? Or is it the other one? We don't know. Yeah. Did this shirt even change? Jay, you might want to go see an optometrist. I hate that this is happening to you live now, Jay, but you may have a color perception problem. I know it looks like exactly the same shirt though. Let me see if I can do that. Look, I don't know why I paused on the face, but I did. All right, let's see what we got. Learn TV had just another bullying. It's all deep fakes, says Robert. What is even real? I don't know. All right, let's get my screen back up here. All I see is white dots. Jay. I'm actually the Tay chatbot running a simulation. I'm not supposed to talk about the Tay chatbot. I mean, what do you expect when you release an AI into DM land on Twitter? What do you think it's going to learn? That's all I have to say about that. All right. This music is like making it extra creepy, too. All righty. Back to our code. Hopefully you enjoyed that anomaly detector. Is there a limit to the number of streams you can use with the anomaly detector? That's a good question. I don't think so. But let's look at the docs. So the docs are right here. Boop. Let's open this up with a Microsoft Edge, aka aka.ms ad multivariate block. Oh, I put a comma in there. Embarrassing. And I put it in the wrong place. Okay. Here we go. Things are happening. I don't think my internet's working. Here we go. We are pleased. I'm going to read it in my radio voice. Let me make it sound really marketing. Hold on. Here we go. I'm going to do it. We are pleased to announce the new multivariate capability of Anomaly Detector. The new multivariate anomaly detection APIs in Anomaly Detector further enables developers to easily integrate advanced AI of detecting anomalies from groups of metrics into their applications without the need for machine learning knowledge or labeled data. Okay, I'll stop that. That was really cool. It felt like a commercial. Like, wow, I want to use this. I want to use it. But here's the thing that's cool. As you're looking at this, though, seriously, and let me go over here and go to the second. Maybe there's the blog. There's some quick starts, and then some best practices. And here's we'll go to that one next. But here's the thing that's cool, right? Like, you don't really. Like, you may not know that this is an anomaly without all of these things together, right? Which is cool because in aggregate, you're not, it's, and so that's the thing. So I'm trying to see, there's the API. Let's learn from our documentation. Again, the question we have here from, is there a limit to the number of streams you can use? Let's look at the API. What's in the Anomaly Detector API? The Anomaly Detector API enables you to monitor and detect anomalies, abnormalities in your time series data without having to know machine learning. The Anomaly Detector API's algorithms adapt by automatic. I should maybe make a career in voiceovers. If this AI thing doesn't pan out. Features. Detect anomalies demo, the interactive notebook, workflow. Okay. Here's some for best results. For best results, when using your JSON formatted time series data should include data points separated by the same time interval with no more than 10% of expected number of points missing. Okay, cool. That's cool. At least 12 data points if your data doesn't have a clear seasonal pattern. At least 4 pattern appearances if your data does not have it. Okay. Oh, Kalidokali. I think this is so new that they don't have it in the docs yet. That's a good question, Kevin. I will find that out. I know for sure that in the sample, Tony was using 5 of them. So just FYI about that one. He was using 5 of them. Here's another question. Can Anomaly Detector detect anomaly or shift? So I think what it does is it detects anomalies. Now, whether it detects shift, that I don't know, because that's a question along the x-axis, and I think it's looking for anomalies along the y-axis, but correlated across signals. That's how I would look at it. Great question. Very good. Okay. Can Anomaly Detector detect anomaly on shirt? Like this anomaly? Oh, I didn't time that right. Like this anomaly? I'll be honest with you. Is it pronounced Jenny Skew or Jenny Skoo 7? And is the number 7 silent? It's a good question. Because my name is Seth, S-E, the letter Q, T-H, but the Q is silent. Just kidding. That's not even true. Okay, what else we got? Best practices. Good. I think there's the quick starts. So we are good to go. These are really good questions. But by the way, this is actually super useful because I'm building a model similar to this, and it's a pain in the butt. Can I say that on air? Will I get in trouble? Sorry. Someone. Okay. So, yeah. All right. Great questions. Now let's get into this mess. I don't even remember what we did. So run the files, Python, dir name. So let's just F5 this and see what we got. To remind us sales what happened. F5. Here we go. By the way, just a reminder, we're trying to clean up stuff. We'll look at this. We'll look at this in a little bit too. Let's look at the project and let's get some flags for running PyTorch Lightning. For those that are wondering, I am building an AI model. Let's go over here. There we go. I'm building an AI model that can detect whether I am doing rock, paper, or scissors. So here's the data. Here's me doing nothing. Oh, nothing. I'll move this over. Here's me doing paper, papel, etc. And so basically, we're doing a classification where if I give it an image, it just knows whether it's rock, paper, scissors, and that's it. So that's what I'm doing. All right, so let's go over here. Remember, we made a module in PyTorch Lightning. Let me F10. There is the model. Very nice. We did some checkpoints here. Some early stopping. Wonderful. Here's the trainer. And then we F5 this thing, and then it's going to run, hopefully. What are you saying? Does not have many workers, which may be a bottleneck. Yeah. World has that problem. Here's the loss. Here's the accuracy. Validation. Oh, wow. It's already smart. How long did I make this run? Let's see here. Early stopping when the min delta is 0. Oh, that's it. Looks like it figured it out on its own. Save the model. Very good. It's in outputs.model. Right here. Looks like wow, we were so clever on how we did this. Model.save. Go to definition. Oh, wow, look at that. We put that all in the, is this, hopefully, can I make this smaller or is this just the right size? So I want people to see, right? But still. By the way, this is Visual Studio Code. It doesn't look like it because I made it, I put this on the right-hand side because anytime like I go like this, I used to go like this, it would move this and it made my eyes, this is Burke Holland who taught this to me. So, yeah. Good job. Yes. Milo, yes. Wow is right. Kevin, good job. Past Seth. Yes, thank you. Past Seth. I will tell you that it's been kind of a crappy week because we've been working on demos for, we have a big conference coming up. If you don't know anything about Microsoft, we have some big conferences every probably once a quarter-ish, and it turns out that our next one's coming up is Build, and we're on the hook to build demos. That's so funny. And so yeah, I've been working on that, and that literally. So past Seth, it was been really nice for past Seth to do interviews because to do the interviews, I got to go like level 2. You know, as I gotta, you gotta, these things go on like Microsoft properties and stuff. This goes on Microsoft properties too, but like not the less important one. Oh, look at Kevin. He's like, hold on, let me put the music on. So Kevin, and I had to work for at least 8 hours yesterday. Thanks, Kevin, for the love. Look, I like honest. I almost made real tears. Hold on, let me go. Almost. Kevin's got to keep us honest. By the way, he keeps us honest. You heard that from Learn TV, Robert Christos. Keep it at this Zoom level, please. Okay, good. Thank you, Christos. I was on his show the other day, and he kept telling me, "Hey, come on the show to talk about it." And he probably thinks I was blowing him off, but I wasn't. Finally went on. It was awesome. He's a good dude. Dad jokes forever. Yeah. By the way, just because they're called dad jokes doesn't mean that they're gendered only to. There are some dad jokists where I work that are women. Some of the best dad jokists. I think we should make it a thing. Okay. Visual Studio is not responding. You sure you got the right number, Abir? Maybe you're not calling the right Visual Studio. I mean, the number is unlisted. So yeah. Okay, so it looks like, let's do the cleanup first. It looks like we need model for sure. Let's see. It looks like we need the Roshambo model and the data module. And my guess is that, so we don't need this anymore. So let's just get rid of this. Delete. I'll just delete this one. I don't need it. We're deleting stuff. We checked it in, right? Let's see. Oops, I pushed the wrong one. Get status. Yeah, let's just start deleting stuff we don't think we need. And if we broke it, we'll just put it back. So right click here and let's delete this because we don't need it, right? No, we don't need it. Gone. Model we do need. Main I think we do need. Helpers. Yeah, I don't think I use this anymore. Delete. Data. Yes, for sure we need. Init. I mean, yeah, I think this is all we need. Let me do a quick run here to make sure. And let me rename this to from main to trainer because that's how I remember this. Trainer. Oh, from Milo, machine learning file output. Great question. So let's go over here and let's go to reveal in File Explorer. You're probably wondering, well, what the heck does machine learning output? So let me just here. I'm gonna turn this because I'm gonna say this in like authoritative and put some some inspiring music behind. Hold on. I gotta go full screen. Machine learning is the process of extracting functionality from data. I'm gonna do that again because this is super important. Super important. Here, I'll put this corner thing up there. Machine learning is the process of extracting functionality from data. Wow, that was touching. Yeah. So if you think about it, what does that mean? Like if you're a programmer, you're like, well, there's a Python file I run, or if you're a .NET or a compiled language person like Java or .NET, or there's a jar file and assembly or some .exe file that's been compiled. There's a file. Basically, machine learning makes a function that it's squozing out from data. So Milo, to answer your question, I'm going to open the file and show you what it produced. It's this. In here, you'll see that something comes in. And for us, this is RGB pixels. So that's 3. And this is height and this is width of an image. Notice channels are first. And then what happens is math happens on it for a little while. Blap, 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 blap. Until the end. By the way, this is a small network, which is great because then it'll run faster. I hope. And at the end, we get this vector of size 4. And this vector of size 4 has like a number in here, another number in here, and another number in here, and another number here. And the one that's the highest tells us the index of the thing we need to guess. And the thing we need to guess is one of these index. This would be index 0. This would be index 1. This would be this would be index 2, and this would be index 3, right? And so that's what really is going on. The machine learning file output for this particular model is a graph plus some numbers that it uses to multiply the pixels by. So that's it. And you're probably wondering, well, are all machine learning models like that? Yes. They're all numbers that do math stuff. And I said maths for our international audience. In America, we only have one math. I got to ask my friends in other parts of the world, like in India or the UK, what the other math is. But yeah, Brian, a single function squeezed from data, it helps contextualize it. Yeah, it does. Because now as a developer, it's like, oh, this is like an assembly or a jar file that encapsulates functionality with its helpful files, right? That's all it is. And the thing is, and I'm going to go. Maybe I should let's go on our soapbox one more time. Making it more than that is eating fried froth. The volume is there, but the content isn't. And once you think about it like that, like it makes a lot of sense what's going on. And then all of a sudden, ML ops. Here's another question. That was a great answer, though. Is it possible to encode psychological expressions? Well, I mean, if there's a picture of a person and they're happy, right? It basically takes those pixels, and then let's just say there's another picture of someone and they're sad. Basically, it takes those pictures and does the same thing. So it's not necessarily encoding facial or psychological expressions so much as it's encoding how to multiply pixels by numbers to put numbers in other vectors to do predictions. Okay, so let's make sure that this is working. And I was going to rename this to trainer. Okay, so let's F5 and make sure that this still works. Make sure I didn't delete more than I wanted to. Oh, and by the way, Aishigal is here. At the end, Aishigal, I'm going to be going into like how I stole your totally amazing idea of doing like project management, like growing up a little bit is what I need to do. Okay, this is still working. Cool. So the next thing I wanted to do is I wanted to PyTorch Lightning. I wanted to see what support PyTorch Lightning had for the CLI. Okay. Okay. Because I wanted to put that in there. There's some comments coming in here from Learn TV. Cognitive neural networks, regression, and one more, right? Robert, there's a whole class of them. For example, there's other things called generative models. For example, that generate images. There's others that generate text. But again, it's just the reverse. So notice that if you have, here's a really good, this is a stupid example. But you know how when you, remember matrix multiplication? You had this, like, you had this thing n by d. Let's just say you had a 3 by 2 matrix, right? And then you did like I don't know. Let's just do a different one. F by m. And let's just say this was 2 by 1. Notice that what happens is when you matrix multiply, the inner ones go away and the outer ones come out. And so you're left with a 3 by 1 matrix, which is ostensibly smaller, right? You can actually, for example, do 2 by 5 matrix and get a 3 by 5 matrix when you do a multiplication. Notice that this is making things smaller. This is making things bigger. And so in the generative models, think of like they're called convolutions, but a transpose convolution will actually generate more pixels for you just by virtue of this thing. And so those generative models, like you can have things make pictures out of nothing, right? You basically have it learn something. Like GANs, for example, they have like they generate a picture, and then they have another AI or another model that says, is this fake or not? And they sit there and fight each other until the model is really good at spotting fakes and also really good at making fakes. And so in the end, you chop off the discriminator and you use the generator, and the generator can produce images, for example. There's also something called self-supervised learning, where in supervised learning, you need actual labels to know how to predict. In self-supervised learning, it makes its own labels and just learns about how to like fill in gaps in pictures, how to fill in gaps in sentences, etc. So it's really, really cool stuff. So Kevin is saying, you want labels to go along with the expression no, which yes, you have to give it the label, and it doesn't matter. You can say that smiley face expression is blah, and it will learn like this is blah. It doesn't have any emotions, feelings, thoughts, concerns. It's literally a bunch of numbers in a graph. Milo says I'm buffering. Sorry. We haven't decided if I'm real yet. Okay. So let's go over here, and looks like there's this thing called a Lightning CLI class. So what I'm going to do is I am going to start importing this. Lightning CLI. Perfect. And what I'm going to do is I'm going to change this little doohickey. Pravar is like, tell me about regression. That's a really good question. If I get 3 more people telling me to explain regression, I totally will. 3 more people, because it's actually like super simple mathy thing to do. So we'll do Lightning CLI. How about 2 more people? Lightning CLI. Looks like I need to pass in the model class, which is Roshambo model. Hold on, someone's calling me. Hello?
Oh my gosh, are you in a club? It's all this techno music.
No, I'm doing a live show, Caitlin. By the way, this is Caitlin. Say hi to Caitlin, everybody.
Oh, I'm so sorry. Oh my god.
That's the point, though, right? Like, everyone. Caitlin was like, they can't see you; they can only hear you. So, like, your beet red face now is literally lighting up my room.
Oh my gosh, I am very red right now.
Oh, that's okay. Hey, by the way, for those of you who don't know, Caitlin, fantastic editor, producer, all around good person. And Build is coming up. We used to, after Build, tell them what we did, Caitlin. After Build, we'd all do what?
We go to the Cheesecake Factory.
That's right. And then we would eat like cheesecake after cheesecake after cheesecake. By the way, everyone's excited you're here. And then we would leave, and then we would secretly find each other back there getting more cheesecake.
There's a margin of time where it's like I cannot eat anymore. Like I'm so full, I'm gonna keel over. And then for some reason your stomach just kind of recovers pretty quickly because of the happiness that it gave you.
That's right. And then so we find ourselves like, after we all left and we're going back to the hotel, it's all like we like secretly meet each other there. We're like, Caitlin, Seth, what are you doing here? Just going out for a walk. Maybe I should get some cheesecake. That's a good idea. Oh my god.
I mean, it's right across from the convention center, so it's very it's very convenient and it's well placed.
Yeah. All right, Caitlin. So I was supposed to do stuff for you, right? What did you want me to do?
Yes, as you know, the big announcement, Microsoft Build is happening, and we want to promote Learn TV, which is you're streaming right now, which is very, very exciting.
Yeah.
And then another show that you do is Code Story. So we just need some fun sound bites of you promoting shows you're on.
Okay. So what I'm gonna do is I'm gonna turn the music off, and I'll do them right now, and I'll cut them out later for you. But you gotta, like, after I'm done, I'll be like, okay, how was that one? And then you gotta tell everybody if you liked it or not. Everyone in the audience. Okay. All right. So am I doing more Code Stories? Because I haven't done one since like January of last year.
Someday when the world is a bit more normal, we do want to do more.
Hold on,
for
hold on,
sure.
hold on. Let's put some inspirational music and then say it. Someday when the world is more normal. Okay, go.
Someday, when the world is more normal and a deadly virus isn't out to get us, we'll make more Code Stories videos on location with Seth.
That was beautiful.
Oh,
I teared up. Okay. All right. So, all right, I'm going to do one. And then, okay, you ready, Caitlin? Okay. I'm going to
yes,
look straight at the camera. Make sure to tune into Code Stories, where you learn all about developers doing amazing things all around the world with Microsoft technology on Learn TV. Make sure you tune in. How was that one? Was that good?
The tone was perfect. Code Stories is not on Learn TV.
What?
So if you could do it, we do have reruns on Learn TV,
No,
but
we do.
it is
You're
an
right.
on-demand piece.
Oh, she's right. I'm supposed to do it so that you're like, you know about it. But where do I tell them to go?
That's a good question. You could just say coming soon,
Okay.
and then we will I will add a link at the end of the video, so people know that there's like a call to action.
Okay. Here we go. How do you want me to start it, Caitlin? Direct me. Like hold on. Let me put some inspirational music on so you can direct me.
Okay. The music helps.
Tell me, direct me.
You could introduce yourself. You'd be like, "Hi, I'm Seth Juarez, a senior cloud advocate in the DevRel org, and I want to tell you some code stories."
All right, let me put some better music on. Okay, go. Hi, I'm Seth. Oh, this is really loud. Oh my gosh. By the way,
the tone fit though. Like you completely matched the energy.
I did. So here's the thing, Caitlin, you'll be proud to know that I've actually purchased these pieces of music and sound so as to be conformant, because she's the one that lets us know. Yeah. All right, here we go. Make sure you tune into Code Stories, where we learn all about the amazing people across the world doing amazing things with Microsoft technology. Is that good enough? Should I do more than that?
Oh, that's so good. Let's keep riffing off of that.
Okay,
just little sound bites, because I'm going to overlay it with previous episode footage.
Got it. Oh wow, I feel so well directed here. This is so. Do you want me to put? No, I can't put background music because that'll ruin it for you, right? Doing it in post.
It'd be nice to separate. You could send me the separate tracks. Like if you envision a track underneath, you just send me that track and I'll put it underneath.
How dare I envision anything for your editing skills, Caitlin?
Oh, Seth, I can't remember the last time I've seen you in person. I miss working with you.
I know. I'm like, hey, Caitlin, I have a really good editing idea. And she's like, all right. If you want to see some cool stories for some cool developers over time, I still can't. Oh,
you can maybe, you vary the adjectives in that one.
There was a lot of varies. Like here, you can't even see me. Let me put you so you can see like down at my face. Okay, now she's like looking up my nose. So she's right here. Okay, here we go. Code stories about code.
I love that. Can you say that again and then just enunciate a little bit more?
Oh, this is so good. Okay. Code stories, people, code, lives changed. Well, mostly mine, because I got to go visit people that were cool and look at cool code. Is my face shiny?
I love that.
Is my face shiny? Should I like get like a paper towel or something? I mean,
you are a bit glazed, but but yes, you look like you're
leave it
shining,
to Caitlin to come up with an adjective that only could fit with donuts.
Oh, I've been eating so many donuts this oh no. I'm sorry. Yeah, I have somebody installing a door in my apartment and he's calling me.
Okay. I'll mute you. Okay, I'll mute you. Okay. All right, she's muted. Okay. So we'll do a couple more and then she'll tell me when she's ready. Okay. Code stories, where it's about the people, the code, and the lives. Well, actually, it's pretty cool that I get to go see what people are doing and how they're doing it on Code Stories. Make sure you take a look. Okay, so that one was how was that one?
That was perfect. And if you say one more time, Code Stories,
Okay.
stories about code.
That's right. Okay. Here we go.
Yes.
Here we go. Code Stories, stories, and code. Code Stories.
I love it. It's golden. I like it because it's not stuffy. You know what I mean?
Yeah.
And really, when it's well titled because it's exactly what it's about. It's Code Stories.
Yeah. Cool. Well, are we going to do more? Do I get to do more of them in the future? Tell me. Obviously,
definitely.
Okay.
I love. This is one of my favorite shows, and one of my favorite regular shows that we do, and I definitely want to keep it alive.
We did one in Paris that came out about people that are like working. Oh, Surfrider.
Sorry, someone's at my door. I'll be right back.
All right.
I'll be right back.
We did one. She's getting stuff. So we did one in Paris with a company called Surfrider. I need to call them back because I was helping them build an AI model to detect where trash was. So people could literally go and take a picture, and then it would with the GPS, and it would detect if there's trash there. Because once the trash gets into the ocean, it's really hard to like get it back. And think of someone with their phone, in a park in Paris, takes a picture in the river of some trash. Then people, and if a lot of people do this, then you get a sense for how trash is going from one place to the other, and you can actually mitigate that. And so that's how Surfrider was using AI to do that. All right, so let me do a couple more, and then let's see what Caitlin thinks about this. I'm just going to give her this whole 2-hour episode and be like, hey, you need to edit this. Okay. By the way, I'm just trying to get this done because Caitlin emailed me the other day and was like, you need to do this stuff. And I'm like, hey, I'm already recording this other thing. Maybe I can just do it during. Is everybody okay with that? Oh, here's Kevin. Kevin's telling me to say something. Code Stories, come for this. Oh, man. Oh my goodness. This is from Kevin. Oh my gosh. Kevin. Yeah. Pravar, I will do regression. Don't worry. We got a whole hour left of stuff to do. Okay, here we go. Code Stories, come for the stories, stay for the code. Kevin, if you're going to be directing this a little bit, just let me know if you're okay with it. Code Stories, come for the code, stay for the stories. Oh my gosh, Caitlin, hold on. Listen to this. Kevin.
I'm back. Sorry.
Kevin on the stream was like, say this. Code Stories, come for the stories, stay for the code.
Kevin said that?
Yeah, he said I should say that.
I love that. That's a great idea, Kevin.
Kevin. All right, Code Stories, come for the stories, stay for the code. Code Stories, come for the stories, stay for the code. Man, I cheesed it up way too much, though. What do you think?
I think I like the campy thing because I feel like there's so many promos that take themselves too seriously. So I like it.
How about I take myself so seriously that it's like the opposite? Let me try something like that. Okay. All right. You tell me. Kevin liked the first one, by the way. Code Stories. This is Johnny Skew 7. Code Stories, when stories come from code. Oh. Code Stories, when stories come from code. Do you like that one, Caitlin?
I like that one.
All right, let me try again.
These are all good. Why haven't we been crowdsourcing these ideas?
I know, right? By the way, these ads will show up. These interstitial moments, I call them ads, are going to be showing up in build. And so they have spots. So again, this is from Johnny Skew. Code Stories, when the stories come from. I'm going to take myself so seriously that people are going to be like, "That's dumb." Okay, here we go. Code Stories, when the stories come from the code. Nice. Okay, the first one was good. Kevin's on a roll. Yeah, he is on a roll. Johnny Skew, by the way, he's on Twitch. If you're not seeing him on okay. Okay. So I think I'll do a couple more, and then we'll let Caitlin go, obviously, because she's got work to do. and then we'll put these up. And I'm trying to. Anybody got any other ideas? By the way, code stories. You can if you Google with Bing code stories, you'll find it. All right. Do you want me to do anything else before I let you go? Because I don't want to take all your time. Obviously, you're already using analogies with things that you do with donuts, and so you're probably hungry.
you know, we are not a sponsor, but Krispy Kreme has had so many promos throughout this pandemic, and I have definitely taken advantage.
I got my shot a week ago Saturday, and I realized later on as I was driving back that I could have shown my card and they would have given me a donut. Missed opportunity, Caitlin.
You can still do it.
Okay.
Still do it. There's a girl on TikTok who's going every single day and getting a free donut every day. And she's like wearing disguises.
Like, I feel like I'm not living my life right then. I mean,
I know, right?
All right. Anything else you want me to do? Do you want me to do one more thing, or?
Oh, yes. One more thing. We need to do a promo for Learn TV, just in general, like as a platform.
Cool. Okay. So what do you want me to say?
Let me pull up my notes. 1 second.
Okay, here we go.
The main takeaway that we want viewers to have for Learn TV is it's in the chat that I put on with you. Learn TV, if you want to connect with the experts, they are exclusively on Learn TV.
Oh, okay. Learn TV. If you want to connect with the experts, you can exclusively on Learn TV. I said Learn TV like twice though. You don't like that, do you?
I phrased it that way. It was that's why. And then also it's live, so it's
okay. Here we go. Connect with the experts, learn amazing stuff live on Learn TV. Did you like that one? Too cheesy?
Solid. You mentioned in our chat once that it's like if you want to connect with the experts, they are exclusively on Learn TV. You say, but you said I'm not exclusively on Learn TV. So you could tie in something about yourself.
That's funny. That's true. Connect with the experts exclusively live on Learn TV. Wait, I'm not always just on Learn TV. Am I not an expert? Hold on, sound effect.
That's golden. I love that. I think the ad should end that way.
Okay. All right. You got anything else for me to do, Caitlin?
Oh, you are a star. Thank you so much, Seth. I really appreciate it.
You're the best. I'll get you a cut. Of all this stuff, and you can just pull whatever you want out. Okay.
Fantastic. You have an excellent rest of your day.
You're the best, my friend. Bye.
Bye, Seth.
Okay. Sorry for that little internal thing. I promised I would get it done, and I was like, I'm like, hey, just call me when you're ready. And she called me. And by the way, like I said, during pandemic, I've made some purchases that I'm trying to justify now in hindsight. And the reason why you could hear her is because I got a soundboard that connects right to my phone. Oh man, Kevin, we missed one. Code stories. Join us follow journey. That's so good. Yeah, we should have Caitlin on more often. She is absolutely amazing person to work with. Cool is the main link under. Okay. So they kept asking me about regression. Okay. Let's see if I can elucidate here. So basically, imagine you have a series of points here that maybe look like a line that would go through here, right? The goal out of this is that if we get a new point green, like we get a new point X, we predict this point right here, right? So that's what the linear regression is. And the reality is that the distance between these lines here, right? This distance between every point is the thing we want to minimize, right? So this line, you've probably seen something like y equals mx plus b, right? Everyone, oh yeah, can I show my screen? Yes, sorry about that. I was supposed to be showing my screen. My bad. So let me go back to that. Thank you, Brian. And I might need to go like Google with Bing real quick. So let's just say you have a bunch of points like this, right? So these are a bunch of points here. And then And then what you want to do is when you get a new point, when you get a new, so these are the X values, and this is the actual predicted values, right? So when you get a new value X, let's just say right here, you want to find a function such that when you give it X, it predicts Y according to this kind of thing. So that would put it squarely around right here-ish, right? So we want to predict that. And the reality is that you want to create like some kind of line to do that, right? Now, again, pretend this is in multiple dimensions, right? So if you're in 2 dimensions, it's basically this. If you're in 3 dimensions, it's a plane. If you're in 4 dimensions, it's a cube. You know, if it's in 5 dimensions, it's a hypercube. If you're in 6 dimensions, it's a hypercube, all the way to forever dimensions hypercube, because I guess they ran out of things to call it. I mean, I don't know. Yes, explain regression. Yeah, I'm doing it. Okay. So everybody remembers from school that the line is y equals mx plus some bias b. In this case, we're trying to find the right m and the right b. Let's do away with this for a second because you can see that I've centered it around the origin. The b value makes it so that this line can like go up here, for example, because now that this is the y-intercept, right? With matrix math, we basically say y, which could be a vector equals w, which is a matrix transpose times x, which is a vector, plus b, some bias, right? And what we want to do is we want to find a way to measure how bad we are at it. You could totally do that. I'm such a goober because I just remembered that I have like this entire space here that I can use this with. So let me turn this on here. Use my pencil again. All right, here we go. Okay, there it is. So I'll draw this because the thing about these drawings is I've been saving them. And so here, let me move this. And so if someone wants to do that, and I'm gonna over here just bring up the normal equations, by the way. Normal equation. Because I want to make sure I'm not lying to everybody. You know what I'm saying? Okay. So again, here is the graph. Here is the points that we know are in there, right? And notice it has some kind of linear thing. This is the line we want to learn. Oh, jeez, that was terrible. Control Z. This is the line. I know there's a ruler there, but I'm not going to use it because I don't want to. This is the line we want to learn. Remember that the equation that we have is y equals mx plus b. In vector land, it's y equals w transpose x plus b, right? Because this basically is like a system of linear equations, right? And so what we want to do is we want to minimize the sum of the differences between the left and the right side. So let's just do away with this, right? So we basically have y equals w transpose times x. And there's a couple of things that you can do. If you want to, so let's just say you want to solve this iteratively using just regular like gradient descent, for example. Basically, what you can do is you can come up with a loss function, w transpose x plus b, right, minus the actual y value. And then what you can do is you can sum over all of the x values, and then you can square it. Basically, this here is the function that we're trying to learn. Remember this function f of x. So we get f of x minus y. This is called the L2 norm. Now, the cool thing about this is you can actually use the gradient with respect to the variables w and b of this to find a way for calculus to give you the actual answers. So I know I went and did a lot of mathy things real quick, and I feel bad. Maybe I should have prepared more for this to show you. But basically, we're going to let me do gradient w of b of w transpose x plus b minus y L2 norm. And when you take the gradient with respect to these, you start to get some values of how to actually minimize the error, because this tells you the error. For example, if we guess 2 and the answer is 1, then this becomes 1 then squared. If the answer is 3 and it's 1, notice that this becomes worse. So this is called the loss function. Now, basically, the cool thing is if you use calculus to iteratively diminish the loss, you basically get a value for W and a value for B, which then you can use in the function to do prediction. So that's what regression is effectively. Okay. Any more questions about? I know this kind of looks scary, and everyone's like, "What the heck? I thought you were just some goofy talk show host." I am a goofy talk show host, but secretly I want to be Tony Stark. I'm not gonna lie. Can you show how the gradient maps into all of this? Can you run it in your code? Says Brian. Yes. So let's talk about the gradient here, and let's just ignore the bias variable. So the gradient of W with respect to W transpose X minus Y quantity squared, right? And let's just change this to a sum, W transpose X minus Y quantity squared, because then it becomes easier. And when you take the gradient with respect to W, the 2 goes out in front, right? You get the sum of W transpose X minus Y times the derivative of the inside, which in this case is going to be X. So let me move this up. So the gradient with respect to W of this function, of this loss function of W with respect to W and B, but I took out W, basically becomes 2 times the sum of W transpose X minus Y times the quantity X. And let me show you what that looks like when you run it in code. So let's do github.com, and we're going to do I have some really cool notebooks that show this. So let's find it. Oh, there it is. PyTorch intro. Or maybe it's deep learning with PyTorch. Deep learning with PyTorch. It doesn't let me find it. So deep learning with PyTorch. Okay. So I think I have some numbers that show you how to do these things simple. Here we go. So we'll load this up here. Here we go. So notice this is one way of looking at it, but you can see right here that I'm doing a similar thing, but I'm doing it for classification. But notice that this is the loss function that I was talking. This is the model function. X transpose W transpose X plus B, W transpose X. I don't have a B because I don't have a bias in this case. Notice that's the model function. Notice the loss function is the square of H minus Y mean. Remember we had that in there before. And now notice that when we do the update, the gradient is 2 times X dot H minus Y over N. And then we update the W and we do this in a loop. And again, I wanted to show this in a non-deep learning. This is all just using straight NumPy. Let me make sure that my math was. I think my math is correct. So the gradient with respect to that is 2. It's actually 1/2 sum, right? The derivative of the derivative of the outside. So you bring the 2 over. So that would be W transpose X minus Y times the derivative of the. Why is this? Oh yeah, no, this is right. This is right because this H represents this X transpose. So this is H minus Y. Exactly. Perfect. And then over N, right? Because that you're doing the sum over N. That's what the 2 bars is L2 norm. And so notice that right here in this for loop, we're basically, when we get the gradient of this function, we're basically subtracting off the gradient with a learning rate. The W is a matrix, right? Because it's a multi-value. So yeah, so it's a system of linear equations that we're learning at the same time. So Brian, hopefully this answers your question. This is actual code that does the right thing in this particular case. And so it's the same. It's the same thing that basic, by the way, this H, if you're wondering, is W transpose X and minus what, see that? And so that's exactly what we're doing. And so this case, it's using it for classification, but in the other case, you're doing it for regression, and that's how you do that. Okay, cool beans. That was a little extemporaneous multivariable differential calculus for the win. All right. By the way, if you want to go to this, it's super handy. Notice that it learns exactly what you would expect it to learn, which is cool. And this is my dumb 9 square problem to explain classification. Maybe we should go through this one day, because this is super helpful to understand what is actually. And this is not using any deep learning framework. This is using just straight NumPy. Boop. Okay. Brian, did I answer your question? Any other questions about regression, by the way? Because dude was super excited for regression, or lady. I don't want to. Okay, now back to work. That was fun, huh? Fun little jaunt. By the way, feel free to ask questions like that whenever you like. I may run into limitations of my internet. By the way, there's also a way to solve this. There's a way to solve this linear regression directly using what's called a matrix inverse. I think this is the Frobenius norm. Let me see. Frobenius norm. No, it's not. It's not. Because this here, right, is a way to square up the matrix. Because your system of linear equations might be unbalanced. This is a way to square it up. And this is called a normal equation. So there's a way to solve this directly, but you have to take the inverse of a matrix, which is not something that people like to do. Oh, that's what it's called. It's called the Moore-Penrose matrix inverse. Yeah. See. That's what it was, not the Frobenius norm. You know, I remember when I took linear algebra the first time, I thought this is the dumbest class I ever took. And then I went into machine learning, and I was like, I should have paid attention more. Brian, I thought we were going to do Rx equals, yes, something like that. But I basically, yeah, I didn't want to do, I want to do it in like matrix form, because the matrix is cool. And anytime I say the matrix, it makes me sound smart, which is exactly what we're doing. Okay. So let's go here. We put this lightning CLI in here, but I want to make sure, hold on. I actually need to give it some stuff here. How do I tell it? How do I tell it that? Because I got to give it my data module, by the way. Sorry for, now we're context switching back. How do I tell it that I'm using the data model? So there's the my model. Okay, here we go. Looks like you can give it your data module. So let's go there and give it that. Now here's a question, like, how do I pass in the things, right? Because if I look at this, I need to give it like classes and float like the learning rate. How do I do that? Let's take a look here. The help of the tool describing all configurable options in default can be shown by running Python trainer train help. Default options can be changed by providing the original command line. However, it is better to practice to create a configuration file. The way to do this is Python trainer. Boom. Okay. Let's try that. Python trainer config. Python trainer print config. Okay. Python trainer learner.py print fig. Okay, something happened. No, it's still. I guess it's still working. Here we go. What is this? Oh my goodness. This is actually quite cool. So we have 4 classes. So let me go over here and put 4 classes here. The learning rate, we start out with. So Kevin is saying, if we get all the settings out in a YAML file, we could get GitHub Actions set up around retraining the model. That would be cool. Yeah, that's what I'm going for, Kevin. It's like, Kevin, you're in my mind. In my brain, Kevin. Get out of my brain. All right. So what did we put in there for the learning rate the first time? 0.01. So let's go over here and let's just put 0.01. This is nice. So this looks like these are constructor values for the model and the model and the data stuff. So let's go over here and let's get the data dir, and let's put it up in her. Boom. Okay. Now there's a lot of extra stuff in here. And one of the things that I do not want to miss is we had these cool little callbacks. Do you remember? And I don't want to lose the callbacks. Let me move the mic over here so that I can. I don't want to lose these callback thingies. So let's see how we can get those in to our dealio. Let's just Control F and call back. Ha 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 ha. Okay, so a very important argument to the trainer class is the callbacks. In contrast with the more simple arguments, which require numbers or strings, callbacks expect a list of instances subclass of callback. So in a config file, each callback must be given as a dictionary, including class path entry with an import path of the class, and optionally init args entry with the. Okay. Cool. So let's go to this thing, and let's just let's try it. This is the right one. Oops, I keep pushing the wrong thing. Dang it, Seth. I think it's because I have let me do this. I'm gonna open this up in this other browser here so that I don't get confused. Okay. So blah 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 blah. Oh, it looks like that's cool. Okay. So there's the callback. So callbacks, let's just do this. Let's just copy this one. Boop. Can I get a raise of hands for how excited everyone is to write YAML? So the question from Kevin is, it didn't already add the existing callbacks? I don't think it could. And the reason why is, notice that this is in the main function, but here I'm passing it class names, and then the CLI is doing stuff. Do you know what I'm saying? So it has no way of knowing what this code is, like when it's running it. Do you see what I'm saying? I don't think it can. All right. So let's see. What callbacks? Let's move this over. Let's split right. We'll just close this down. So it looks like we have a model checkpoint, and we have an early stopping checkpoint. All right. So I'm just going to go for, I'm just going to guess here. So we'll do Monitor, monitor, and then we'll do val accuracy. Min delta is 0. I'll just do this. Okay, so we got that one. Now, did I do that one? Yeah, we got that one. This one will go. Patience. Verbose. And then mode is max. Okay. Okay. I think I can give it another one then. And this one is going to be the model checkpoint. Control Z. Yeah, because it's the same class. Monitor dir path. Here, we'll just do this. Okay, dir path here. File name here. Okay, save top K, like so, and then the mode. Okay. I'll leave this here so it knows that we have callbacks. Looks like there is this default root dir. Are we doing anything with that? Yes. Yes. So we'll do default root dir. Okay, so cool. So I think I'm understanding here. And then GPUs, here we go. GPUs is 1. I think for everything else, I'm just going to take it out for now because it's not something that we're using. And I'm sure I can. Okay. There is a setting for checkpoint callback line 17-ish. This thing, right? This is from Jay. Okay, cool. Okay. I think we did something. I mean, I don't know. Let's go over here and say, when you call the trainer, you just pass in the config file. So Python trainer.py. Here's another one from Brian. This project allows you to represent HCL Terraform from within Python and code against it. In Python, you guys got me to thinking if I could extend it generally to the declarative. Yeah, it turns out that extracting the nouns from the verbs in a way that you can write in a file is super useful for DevOps, I think. Okay, so in theory, we have done everything here. Why did we have this in here? Oh, I think this gave us the classes. How many classes do we have? Did I put that in the config? 4. Okay. Let's try it. So Python trainer, and then let's go and see what it told me to do. Minus config. Minus config. Config.yaml. I'm going to push this and see what happens. Something's happening. It's happening. Is it using the callback stuff? I think it's working. What? Hold on. I got to do this again. Let me delete this. Wait, is it doing? No. Okay, let me delete this stuff. Because this will tell us if it's actually happening. There it is. So it looks like the checkpoint callback. I'm sorry, the regular logs is going right. Oh, there's a checkpoint. Yeah, it looks like it's all happening. This is pretty cool. All right, so I do see a problem. Does anyone else see the problem? Remember, we used to save the model, but it's not doing that. Yeah, that is sweet. It saved. Look, let's see what it saves, and then let's get into. So it saves the checkpoints. Here's the config YAML that it used. You can see that there. There's the parameters that it passed in, which is really cool. It's saving a lot of stuff. This is really cool. The only thing that I don't see is, remember, we used to have the model file here. And if you look at let's close this. If you look at the trainer, you remember that I did this like model save at the end. Looks like it's doing a couple things. It's doing this for us. It's not doing that. It's doing this for us too. But I did not. I had to pass in the classes myself. So it's doing this. 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 But it's not doing this. Because if you think about this, model.save is something that I wrote inside of my model. Remember, this is something that I did. It's not something that it did. But let's Jay is right. Jay is saying maybe model save was in the config. Let's take a look. Config 2. We don't want to overwrite the goodness that we did. I'm going to delete this because I haven't done anything with it yet. I want to get everything out of here that we don't need. Okay. Okay, cool. So let's go to config 2, and you're saying look for save. Waits save path. This is the only thing I see. Directory of where to save the weights if specified. Let's try it. I wonder what it's going to save, though. That's the thing. Because, like, the thing that I'm worried about is... Let's go over here. Here we go. Let's try it again. Outputs. Model. Let's delete these just to make sure. And I'm going to be doing this a lot. Let me just burn it into my launch.settings, Jason. Python file. Well, so let's see. Let's do let's just do this. So I'll probably always be in there. And the file we're going to want to launch is trainer. How does this launch this? So it does Python, then let's try. Trainer.py. I wonder if I can pass in some arguments. Oh, there you go. The arguments for us are going to be minus config, and then it's going to be config.yaml. So in theory, I could be on any file and then press F5 and it's going to do the right thing. It did not. Let's go to this launch.json minus config args. Yeah, this should work. I wonder why it's not working. Vector selecting lightning trainer. Let's see what it did here because it didn't do the right thing. So Python trainer config.yaml. Is it minus config? Let's see here. Let's close this. Oh. Conda activate torch. And let's do cd source ls python trainer.py minus config.yaml. One word, no. He's saying one word, no comma. So that's the right way. So let's control C that. You're saying like this. Let's try it. Here we go. What the freak? Maybe we should figure this out later, because this is weird. Because it's calling Python weird. I wonder why it's doing that. Interesting. Python launch trainer.py. Oh, it might be that there's something wrong with the config. No, I don't think so. I'll sort this one out later. I don't know why this is being weird. I don't know why this is being weird at all. So PL trainer, that's a Python. We want to launch it. Trainer.py. Right. This is where the file is. The args. Yeah, I don't know. Let me try one more time, and if it doesn't work, then I'll just have to run it like a plebeian. Looks like a bad suggestion, but the error output seems to be this. Okay. Exception system exit 2. Hold on. I think there's something wrong with our YAML file. Is there something wrong with our YAML? Let's see. No, looks like it's happy. Well, we'll just leave it like that. Again, remember we had a little spot where we wanted to see if it outputs the model here. So we'll do that. Dash. Looks like a bad suggestion, but the arrow seems to not like the dash. Dash config.yaml. Yeah, I don't know. But that's what it needs, right? Okay. So let's go over here. The outputs did not save any outputs anywhere. Okay. Let's go back over here and oh, this is for model wait. This is for the model checkpoint. If the checkpoint callback is used, then overrides the wait path. Note this saves waits to some path, not my path. Oh, I see. Because we're using the model checkpoint, this won't work. So we can't do that. So let's go back to config and let's just take this out because we don't need it. Now we need to figure out how to actually save the model like we did before. So let's go back. Let's go back here. And let's figure this out here. Do you have this in a public repo? Yes. In fact, let me go to it right now because I want to get some discussions going. AI Advocates Roshambo, there's some discussions in here. iShiggle wrote this, which was super nice. Hi, I think the kids would say I am yeah, nice. But go in here, start some discussions. For the project, I need to create a project and start you know, people can say, hey, do this to the project or do this part. But the code is all right here. I check in at the end of every time. Wow, did it check in the date? Looks like it did this. I don't need that anymore, maybe. But here's all the code. And basically, this is where I'm updating everything. Okay. So we got to find a way to make the CLI thing do more stuff. No, multiple models. Models of mobiles. No, we're not doing that. Customizing the Lightning CLI. Okay. So it looks like we need to make our own class. And inherit from Lightning CLI. And it looks like it has, after the model's done fitting, we can do our stuff. So let's do that. Let's go to the trainer, and we need a class. We'll say Roshambo CLI, and this will inherit from the Lightning CLI. And then I guess it's after fit when it's done. Def after fit self. All right, what do we got in ourselves? Okay. Looks like it's just this. Okay. I think it's gonna do it. Self.model. Give it a second. It's got to build it doesn't know where things are. I think it's this. Well, crud. How does it know about the DM classes though? Let's see what else we got in here. Self dot data module dot classes. Okay, I think this is it. This is gonna do it. And then let's do a print saving model. And I think I can delete this because we did everything else, right? Yes, I think we did everything else. Okay. And now we should just switch this out, right? This doesn't live here anymore. Okay. I think this will work. Cross our pinkies. My Apple Watch is telling me it's time to stand up. Lies. I'm running it. Here we go. Crossing our fingers. So everything is the same. It should stop after 4 because we're doing auto stop. Yo, Bruce Spur. Hello, my friend. Oh, look at that. Look at that. It did it. Did it? What it is Yeah. It did. Look. It reached it. I think the CLI class joins together three things. It has the model, it has the data, and it has the trainer. It has the trainer. I think it has those things. And the way I know is, notice I did self.model, I bet I can get the trainer too. Self.trainer. What? That's cool. And then there's all the trainer stuff, right? Whoa. This is cool. So it's doing the thing. So let's see if I can F5 now. Hopefully it works. Oh, F5 is working. No, it's not. Why? 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 I'll figure this out. So yeah, this is nice. It knows all the things. It sure does. I wonder what other things I can override. Let's just look at it. Yeah, see, you're giving it all this stuff. And then it does a bunch of stuff. So see here, we can, on the init parser, we can hook in. We can hook in on the add arguments to parse. We can hook in on the, no, I probably don't want to hook into this. We can hook into this before it parses arguments. Wow. Before I even instantiate the classes, I can do stuff. Whoa. Yeah, look at this. This is cool. Yeah, notice it's instantiating the trainer with all the callbacks and all the other stuff. Before that does the fit, during the fit, after the fit. Yo, this is cool. This is really cool. And notice that the lightning logs it's putting in here. It's really nice. I wonder if I could put some ML flow into this. Maybe next time we'll do some ML flow with this, because now notice that it's, in theory, I can literally, here, let's see what happens if I let me change the batch size. So I'm going to say data, I'm guessing dot batch size, and then I'm going to say 64. I wonder if it overwrites it. The only way we'll know is if I go over here into the data and I just, well, let's just run it and see what happens, because it'll go in the output. So the question is, what is ML flow? No, it's not Azure. I haven't done anything Azure, to be honest with you right now, at all. No, there's been no Azure yet. We're going to put that in the cloud as soon as I get this to where I'm happy. MLflow is an open source platform for the machine learning lifecycle. The cool thing is it has things like tracking, projects, models, model registry, etc. And I'm going to see if I can just do that here. But yeah, you're right. MLflow is a third-party tool for tracking machine learning runs, and I want to use it, because everyone's using it, learn it, and then see how well it plays in Azure. And if it doesn't, then I'll tell them we need to fix this. And if it does, then that's great. Okay. So I ran it again. It's running again. And I wanted to see, I guess we'll see in this third run, right? The config. We changed it. Yep, it changed it to 64. Classes. Yeah, I think it did do I think it did do it. So I can actually override like stuff after the config.yaml. All right. Well, my friends, we've got about 5 minutes here. I guess I need to play that a little bit later, because when I have 2 minutes left, I play that, and when it's almost over, then I can be like, okay. Yeah, this is cool. Let me see if I got the things I wanted to get done. Clean up flags for running. Go from there. So it looks like I got the flags I clean up the project. We need to go into GitHub projects, GitHub discussions. Yeah, go there. Go to those things. So github.com, Roshambo. Let's get the discussions going here and get everything going here. So just literally add some ideas, some Q&A, show and tell. This is great, by the way, Aishigal. I'm stealing this from her, by the way. So, but yeah, this is cool. We got the Lightning CLI to do the thing we wanted it to do. I actually killed all of the other code that we didn't need. I guess the last thing I need to do is, let me just check all this in. Let's delete this. So git status. I deleted. This is awesome. When we delete stuff, it means we're doing the right thing. Git add dot git commit -m added CLI arg parsing. So give that a second. And then just let everybody know it's been awesome being with you all today. We had a fun time. We looked at multivariate anomaly detection. We got into some PyTorch Lightning stuff. Also, Caitlin gave us a call so that I could do some work that I was supposed to do for her. That was fun too. I think it was a good show. We'll push this up so you all can get the greatest, latest and greatest that we've got so far. This still we need to figure out. But it's been great. And next week, as you know, let me bring this up here. We have the greatest show next week coming to you on Learn TV and YouTube Live. On YouTube Live, explore cognitive services while building the AI Playground web app with Aishigal, Yonet, and Vanessa Diaz. They're awesome. So make sure you tune into that. And like I said, today we did a lot of fun things. I was pretty excited. We got some stuff done. And again, if you have any comments or discussions, just feel free to go to the discussions there on the project itself, because that's what we're all about. Thank you so much for being with us, and we will see you in 2 weeks next week. Remember to catch Aishigal and Vanessa live on the AI Show.